In this video, we're looking at a lab situation where we have two vectors that are force vectors, and we're going to add them together and check and see if they equal the third. So there are three spring balances represented by this diagram, and these are all drawn to scale. And basically 1 centimeter is going to equal 1 Newton in this scale. So vector A is 5 centimeters long, but is also representing 5 newtons. So there's a spring balance pulling in this direction. Then there's one going in 3 newtons in this direction here, and that's vector B. And vector C is off in this direction here. Now A plus B should indeed equal C. So what we're going to do is we're going to vector add these together by parallelogram method first. Okay, so here goes. I'm going to translate this vector here parallel to this vector here as best I can, or I'm going to make this parallel and connect it to the tip of this vector as best I can. So here goes. I need to make it parallel and the same length. And then all I got to do is connect the dots. And here's my parallelogram. I could have drawn that better, but you get the idea. So then I'm going to draw in my diagonal to my parallelogram here. And that diagonal represents the resultant vector. Now we're going to need to measure the length of this vector here as our diagonal. Okay, in doing so, I measure it with a ruler, and let's say I come up with the measurement of C, and we're going to call this C prime. The length of this vector is C, but we're calling it C prime so we don't get it mistaken by this one here. Let's say that comes out to be 6.1 centimeters, so therefore 6.1 newtons. Okay, now we have a parallelogram here, so this is side B, but this side here is also side B. And what we want to measure is angle B here, from this line all the way to there. And let's call that angle B for right now. Now let's say angle B measures out to be 29 degrees. So these are known as our graphic measurements. We have done this using a protractor and a ruler, and we drew our parallelogram. Again, probably could have been a little more parallel, but you get the idea. Okay, so what about calculating mode? Well, we don't have a right triangle here. So we are going to have to use the law of cosines. So it's c squared equals a squared plus b squared minus 2ab cosine of c. Okay, so now this is side C. I know we call it C prime, but essentially side C. Therefore, this is angle C here. Our angles are always opposite our side. So how do we get that? Well, we have to measure the angle from B all the way to A. It's the beginning vectors we must go back to. We're not going to do the parallelogram. We're going to measure this. Well, let's say that comes out to be 80 degrees. Well, this angle and this angle inside of a parallelogram are supplementary, meaning they must add up to be 100 degrees. Therefore, I now know that this angle here is 100 degrees. So now I know that this side C has a 100 degree angle opposite. The side B has an unknown angle B next to it. Okay, so that's how we're going to solve everything here. Okay, so C squared we don't know equals A squared. Well, I go back to the original data. That's a 5 squared plus B squared. Well, I know that that side is 3, so 3 squared minus 2 times 5 times 3 times the cosine of 100. Now, performing the mathematics of that and square rooting, we do get a 6.3 newtons for the resultant vector by calculated means. Okay, well, we need to get angle B now and compare that there. So we're going to invoke the law of sines. So we're going to say the sine of angle C divided by side C must equal the sine of B divided by side B. Well, we now have C to be 100 degrees, and we've calculated it out to be 6.3. And we'll set the equal to the sine of B divided by B's value of 3. Okay, now we have a proportion here. So we're going to crisscross that. So we have 100 times 3 equals 6.3 sine of B. I'm going to divide both sides and solve for the sine of B. So let me write the sine of B over here. Sine of B is equal to 100 times 3 divided by 6.3. So then I need to know what angle B is. So I need to take the inverse sine. I want to know what angle makes this ratio possible. So I need to go inverse sine or second sine and place this into my calculator. Okay, and it comes out that angle B is equal to 28 degrees. So I'm going to put that over here, 28 degrees. So these two answers here are the calculated version of it. I'll just abbreviate that calculated. In the next video, I will show you how to place all of this data, okay, into the data table, and we'll also look at finding C prime double.